welcome back. I believe most of you have followed the introduction to AI course, so familiar faces, and I'm a familiar face. I'm going to teach this class together with Michael or Michael. This guy, he's going to take over the parts on machine learning and reasoning with uncertainty, and I will talk about the state space representation search part, and at the end about the logic part and knowledge representation. The course, of course, is not taught by two people, it's taught by a whole group of people, and these are the names in alphabetical order, apart from some mistakes I made in the ordering of the people who help or are also involved, and these are all the TAs that you're going to see, or some of them you're going to see. Today is the first lecture, and the first lecture is obviously an introduction to the topic so that you have an idea of what to expect from the course. It's also an introduction to what you have to do in order to get the grades for the course. And I also want to start with parts of the technical material. So introduction to AI was a general overview, getting the ideas, getting some first insights into some of the algorithms. And now we really try to systematically get you to understand the idea of how to build an intelligent system, how to build an intelligent agent, the first AI that you're going to build. As you can see, I'm trying to record the lecture, and I will put it online, try within 24 hours a link on YouTube, so that you can see what I try to explain. Look at it again, look at it in half speed if you want, look at it in full speed if you want, double speed. You even get subtitles from YouTube, so that's really very cool. So we already have recordings from last year, so they cover more or less the same material, but in different orders and different, also different depth, because it used to be a second year course. So the link has been provided. You can already look at it in advance. Please do so, because then you can follow the material more easily and you can ask questions if you want. So, I don't know what happened here. Let's do that again. So the course is taught by Michael and me, plus the TAs who you're going to meet. You're going to meet them on Thursday and Friday, depending on which group you are. There will be one working group in which we practice the theoretical material and prepare you for the exam. And there will be computer practica where you can get help if you want to. So you don't have to come to any of the lectures or working groups or computer practica, but where you can get help if you fail to do the worksheets that we provide on your own without help. And I should start with a word on the programming, because I understand that you have started with the first lectures in Python today or yesterday or maybe tomorrow. And if you look at the first worksheet, you will probably be rather shocked that there is already some programming we expect from you. And the programming that you would need in order to, or that you need in order to do all the exercises for this course are far more advanced than what you know now, or what you even know in the first 3 weeks or 4 weeks. So what we give you is not the task of implementing everything properly in the practical part of this course, but what we ask you to do is really do your best to try and do so. So I'll get to that back when we talk about the assessment of the practical part, but don't panic if you now see worksheets where you think, oh my God, I have no idea what the task is. We know that, and we take this into account. So the advantage of having this course now, directly after the introduction to AI, is that all the introduction that I did in the AI course, introduction to AI course, isn't needed anymore. So I just have a very, very quick repeat of what I explained in the first lecture. Now the question is, I started with the video of the series Person of Interest. Did anybody started to look into this series after the first lecture of the first period? Yeah, someone did? Still do if you don't, but that's what I expected. what I want to remind you of is the story that is told there, and which I think is quite close to what we can already do, or quite close to reality. And that is that it's about a machine that is an intelligent agent that has cameras and microphones, sensors, and the only thing it has in the beginning as an actuator is a telephone, and it only gives back numbers. So it's a very intelligent machine that has very restricted input and output, particularly the output, I have to say. And the main task that it has to do is to classify whether people, ordinary people, are in danger of becoming the victims of the perpetrators of a crime. And then this crime is going to be stopped or not, and that makes it a sort of a watchable series. And these tasks of classification and decision-making are really central to most of the intelligent systems that we deal with in our daily life. And the tasks that you have to use are core AI tasks. So you need to do text processing, image processing, data integration, knowledge representation, automated reasoning, machine learning, genetic programming. These are all things that this machine does. And some of them we are going to look into in more depth. Some of them we don't. So this is not a course about image processing or data integration, and also text interpretation is not part of what we can cover here in this first course. But you will get courses later that cover, for example, text processing. What is, I think, common to what we are going to see throughout this course is the idea that this intelligent machine has the goal of performing optimal with respect to a set of measurements, some criteria, some expected outcome. And this expected outcome is to give as many of the social security numbers of the people who are in danger without giving any false warnings or so. So that is the objective that this machine has to solve. And what it does is to try to find the best estimate that it can get to give one of those numbers. There's no perfection involved. It just tries to get as much information from everyone. Is that science fiction? I don't think it is really. Of course, it is a bit exaggerated. We can't do that stuff, and luckily we can't do that stuff at the moment, also because the data is protected and so forth. But it is very close to the kind of complexity that we can deal with now, like the AlphaGo that you have all heard of now, the Google driving car, the Siri or Alexa language speech recognition, or the more knowledge kind of AI where a system can answer any kind of natural language question better than humans can. And it's not perfect what Watson does. I think that is clear from also the presentation that Chris gave. So Watson is also doing loads and loads of mistakes, but it tries to give the best answer to the question according to the means that it has, and that is data that it gets from sensors or the reasoning capabilities that it has to give you the best prediction. So I showed you this this link to these the Google experiment pages, and I can really recommend you to look at, to go to this website and play around with some of these tools, because some of them are really, really impressive. So this one is one you need a camera. The camera takes a picture of any object, and Google tells you what this object is. And this is dramatically difficult, but we're nowadays so far that this can really be relatively reliably done by machine learning as a basis. And we're going to see that in the second part of the course, that how to do these, how to write these algorithms that can recognize these kind of images efficiently and effectively. The other part that is more where I do my research on is the knowledge part. And I think Frank gave a very good presentation here about it, that nowadays all the companies that, the bigger companies anyway, so Google, Microsoft, IBM, eBay, and so forth, you name it, they build their business models on the basis of knowledge graphs. I know it from Elsevier, I know it from Siemens, but I also know it from smaller companies, I know it from the governments, and so forth. So it's really has become one of the core knowledge representation means for businesses and public organization and so forth. And this creates enormous amounts of problem because we need to organize this knowledge, we need to access the right knowledge, and so forth. And that, again, is part of what we need an intelligent agent to know and to be able to deal with. Very concretely, what we are going to do in this class and the sister class in period 6, so in June, is to address a problem that's called Schnapsen. And Schnapsen is an Austrian-Hungarian card game. It's a trick-based card game. So I think I have a Kahoot for this, and let's now see whether that, no, not a Kahoot, a Mentimeter. Let's see whether that all works. That was the idea, should be here. And here comes the first question. So if you would go to the menti.com, user code 778888, and then there are 4 options, and I'd be interested. Yes, are you rather good at Schnapsen? Yes, you've played it occasionally. You play trick-based card games, or you've no experience at all. Yay! Who's this one person? Where are you? So when we prepared the first version of this course 2 years ago, I regularly played this with my daughter, and I really, really like the game. It's very entertaining. It's a nice thing that you can play it with 2 players, and it has a lot of aspects to it. So I think it's clear that very few people have played it. I would really recommend you, and that's the homework that I give you for tomorrow, if possible, start playing Schnapsen. Get a glass of beer, get someone, explain the rules to this person, and start playing Schnapsen, because you need to understand it. Probably this week is too short, so let's do it for next week in any case, so that we get these numbers up to the hundreds. And why in God's name do I want you to play a card game? And this is the explanation. So this is the game environment that one of our students has written 2 years ago, in which you can build your own intelligent agents against you, and you can play against it and show your Schnapsen skills. So I've prepared this. So this is my command line in which I've started all these things. Oh no, this is the command that if you download the game engine as it's explained on the course page, then you have a part on visualization. You just have to start a Python server which holds the intelligence against which you play, and you have to tell it against which opponent you want to play. And RDeep is one of the intelligent agents that we give you. Yeah, so that is now started at the back of my computer. It runs, and it has an interface on a website, which I will also show you. And this is this one. It has this weird name, 127.001/5000. And this is where this machine now waits for you to play Schnapsen. And as I said, it plays now against one of the intelligent agents that we've written, that we've provided, that you have in your distribution. But at the end of the course, and particularly at the end of the June course, you will have your own intelligent game played. And the idea is very simple. You have a pile of cards. So these are 10 cards. One of them is open, and that's the trump card. So it's a heart that is trump in this game. And there are 2 phases to the game. The first phase is that you have 5 cards, and they are open to you. They are not open to your opponent. So this is the 5 cards that you have. And in the first 5 tricks that you play, you have to play a card. So in this case, I start. And your opponent doesn't have to play the same color. Yeah, so it's a different game in the second half. So you want, in the first half, you want your opponent to get as few points as possible. So I start with this one, for example. I submit the move, and now it's the AI that makes the decision, and that takes the 12 points that you get for this. And what happened as well is now, after this part of the game, we both get 2 new cards from the pile. Yeah. So in the second phase of the game, in the second trick of the game, we both have 5 cards again. So now he played this card. I can win it, and I will quickly move through the first 5 tricks, because then you will see what happens then. So now it's my turn. I play this card. There is a special thing that I can announce, and that's a marriage that gives you extra points. Then I choose this one, and the game continues. So I continue until the pile is gone. So let's be quick here. Submit the move. So here above you see how many points I get. So now I have to submit a move, and now we've come to the second phase of the game. Yeah? So the pile has gone. There's no cards to get back anymore. And a very important thing about this situation that we're in now is that if you counted correctly, which of course you have all done, you know exactly which cards your opponent has. Yeah? So in the beginning we didn't know which card the opponent had, but now we came to a moment where we know exactly what the opponent has. So we've turned from a situation where we have imperfect information to a situation where we have perfect information. And now I can, in principle, systematically calculate all the possible ways this game will continue. And this is what we're going to learn next week, how you make a machine do this, namely find the best strategy for playing the next card if you have a perfect information game. And in the next weeks after, we move to techniques that also help us for the first week. For the first phase, where we don't have perfect information. Yeah? So now the game is almost over because I have 56 points and my opponent 52. And the opponent played the card, and I now have to follow. I have to now play the right color. I submit this move, and my opponent wins. I can tell you that this is a relatively straightforward bot, as we call it, intelligent agent that we implemented here. I will explain it in 2 weeks or so, how it works. But it's damn hard to beat. So even if you know very well, if you can implement clever techniques, clever rules, it's very difficult to beat this very simple bot. And in period 6, so when the first year is almost over, we'll have a project in which you have to do research on what kind of AI technique do you need in order to write the most powerful and the best performing AI to win in these games. And don't get me wrong here. This is a very simple game. So it has 20 cards. 5 of them are open. It has 10 tricks. And still there is no machine that consistently wins against humans. So in that sense, it's a more difficult problem than the AlphaGo problem. And that has to do with the fact that it's an incomplete information game. So because we don't know what in the beginning actually happens, what cards are where, and that makes it a very interesting game to play. There are publications in the best AI conferences on people who try to write these kind of agents. And this is going to be our sort of example of building an AI intelligent systems in the coming weeks. So that is why it's very important if you really try to get a bit familiar with this game. So much for this. So I already mentioned some of those properties. It's an adversarial agent setting. Adversarial games will be covered next week in the lecture on Wednesday. It's imperfect information game in the first phase, and that makes it incredibly complicated. And what Google did for AlphaGo, we do now for Schnapsen, and obviously we are not going to solve it with high probability because it is a very difficult problem. But we want to understand it better, and we want to use it for some research. In this first phase of the course, we are mostly teaching about the theory, and the practical research and development we do in period 6 when you know more about programming and about the logics and so forth. So some of the ingredients of AI and intelligent systems already came along, and that are 3 main themes that this course also has. And the first one is search and heuristics. So basically what you had in this second phase of the Schnapsen game was that I had 5 cards and my opponent had 5 cards. I know what my opponent has if I have a good memory. So I can calculate all the possible situations if I play this card and he plays this card and I play this card and he plays this card. I only have to do that 10 times, and then I know whether I win or not, because I can just count the points. And I just have to do that systematically through all the possible options and actions that I can take. All the cards I can put and all the cards he can put down. Here you see this on chess, because the idea behind this is exactly the same. So you have chess, you have one board position, one state as it's called, and you have, let's say, 15 figures that you can move in different directions. So you have 20 different choices for going from this board to any other board in chess. Okay, so you have your 20 choices here, and then your opponent it's your opponent's turn. And he again, or she again, has 20 also different options where to move the figures. So you see that in chess already in the second move, you have an incredible richness of possible board positions that you can reach. So in order to win the first chess games, people had to control this search tree. And how do you do that? You usually use heuristics. Heuristics is human knowledge where you say, okay, I have an estimation that this chess position is better than this chess position. And that is, for example, that if I know that if I have more figures than the opponent, then I usually have a better chance of winning the game than otherwise. But then the question is, what is the value? If I have the queen, then my chances of winning are higher. And these are rules of thumb or knowledge that I can formalize. And I formalize them in so-called heuristics. So that is the first part of the course. That's what we're going to do this week and next week. The week after, Michael will take over, and I think a most recognized part of intelligence is that you try not to make the same mistake all the time. So you learn from your experience, you adapt to your environment. And there are different ways of this adaptation. So you can sort of try to abstract away from a series of measurements into a different representation form, such as from measurement points to a function. So that's a different representation based on some data. You can also learn to recognize some concepts in the world. So this is the link to the knowledge graphs that Frank explained about. So you can look at something, and even if you haven't seen it before, if you know the main properties of it, you can recognize that this is a bird. Wow, well, how does it come? That's very difficult for a machine. And we're going to look into how this is going to happen in week 3, 4, and 5. There are different forms of adaptability, and we're not getting that much into them, like evolution, for example. It's a very typical example of a system that learns from the past experience and improves on this experience. And the last topic is the one that Frank gave the lecture about knowledge, where the knowledge graphs are only part of a way of representing knowledge. There is a lot that we can represent in some kind of abstract mathematical representations. There is a huge amount of written knowledge or semi-structured metadata available, knowledge available. There are, for hundreds of years, we're now looking at classification schemes at Thesauri and so forth. And the question is, how can we make use of that in the building of our intelligent machines? There's also knowledge that hasn't been necessarily explicitly given by humans. So I can tell you every bear is a mammal. But there's also more knowledge, and that is knowledge that we can derive from the structures in which data, for example, is given. So we know, for example, network structures, and we can derive notions such as popularity on these network structures. And you all know that, you all use it every day in a search engine. The idea of PageRank, which gives you the highest ranked, most relevant website, what made Google what Google is now, is based on this algorithm, where you have an estimation of popularity via the structure of the graph, where you have if you have a random walk algorithm, so just things that walk randomly through the graph, then the probability of one of those beasts arriving at the most popular nodes is the highest. That's the definition of PageRank. And there are different ways of calculating this nowadays, but this is the idea that there is some knowledge in the structure that we can interpret and from which we can learn. And we're going to look into these kind of things as well in week 6 and 7 of this class. So the basic knowledge you will have at the end sounds very mundane. It's about state space representation. So let's take a problem in real life, like Schnapsen or driving a car and so forth. And can we make a generic representation formalism so that we can always use the same algorithms on them for all the various problems that you can face as an AI agent? And then when you do that, when you can describe a game such as Schnapsen or riding an autobus or whatever, then how can we find the optimal solution, the best to our problem that we can reach? And the answer is through search, and that is part of the first 2 weeks, what we're going to do in the first 2 weeks. We need a notion of agent. That's what I'm going to talk about today. So what does it mean for an intelligent agent in the first place? And then we're going to look into machine learning and knowledge-based reasoning. This is by no means a complete overview over what AI does and intelligent agents do. As I said before, there is planning, natural language processing, robotics, perception, scheduling. So there are many, many different topics. Some of them will come back in the curriculum in the next years, and some of them you will have to specialize in a master and so forth. But the basic skills is what we are going to look into in this course. In the practical part, we want you to start thinking of the Schnapsen game in terms of this state space representation and then apply search and adversarial search in particular for finding the best strategy to play the game. As I already said, this works for the second phase. It works very well because it's a perfect information game. So the algorithms that I explain next week will really give you an optimal way of playing the game. But because of the first phase of the game, it's an imperfect information game, we need other methods such as learning strategies, heuristics, and some Monte Carlo sampling and so forth. And then there's also a lot of intuition and knowledge that we have as humans, so we can also try to see whether we can represent some of the human strategies in the game with some logical algorithms, some knowledge representation methods. And that's what I'm going to talk about in the last 2 weeks of the class. So the course will be about decision-making in principle, because that is all what it all comes down. And it's not just a decision for a specific problem, but it should be efficient, simple, correct, well understood, and generic. We want to come up with algorithms and methods that we can apply on the one hand on Schnapsen, but in very similar ways, in principally understood ways, also for the self-driving car. That is what specifically is about the AI. We're not looking at one specific problem, but we're looking at the generic kind of intelligence or methods that you need in order to make some intelligent behavior. If you want to finish this course, which I think is, of course, one of the main objectives for you to optimize here, then at the end of the first week, you have to understand the basic concepts of what an agent is, what state space representations are, and what heuristic search is. And then you need to know the main algorithms, such as min-max algorithm with some kind of optimization, the famous A-star algorithm, which we're going to look into on next Tuesday. And you have to start to play around with these game engine. So I want you to at least to be able to play with this engine, to have the the Python code installed. And then we have provided some tools, some bots for you, some agents, where there's just one line of code missing. So you need to understand how this all works. And that is more complicated than what you know about Python and what you will learn in the first weeks. But I really encourage you to try to go through the code. It's well documented. You cannot break anything. If you've sort of messed it all up, you just delete everything and you download it again. So there's really nothing you can break. Play around with it, and that's basically the task for the next 2 weeks, I would say, for you to get familiar with this game platform and the way of writing these kind of things. And if you hear fancy words that you don't understand, such as object-oriented programming and recursion, just ignore and try to understand anyway what it is. Just go through the code and see what happens and calculate it through maybe with some simple examples. There will be 4 lectures, so 2 this week, 2 next week, and 2 practicals and 2 computer practical, working groups and computer practicals, and you should all be registered to each of those groups. There are some few people who've contacted me that they have been scheduled the same time. So if you're one of those people, if you would come to me after the lecture, not on the break, but after the lecture, that would be good. Then we can see what we can do for you. Yeah. In the second week, the principle is the same. There's 1 more lecture on uncertainty and machine learning in week 3, 4, and 5. There are again 2 working groups and 2 computer practica to get you going on this. And the idea is that you understand the main concepts of approximation, how to deal with uncertainty, how to deal with the fact that you do not know what cards your opponent has. And again, there are principled approaches for doing that. And then, of course, it's about the basic concepts of machine learning, the main idea with learning with the neural nets, and maybe some basic ideas how to train a deep model and so forth. Again, there will be an assignment for you to implement an adaptive agent, and this sounds huge, but it's relatively small. And Michael is going to explain that, how to do that in 2 weeks, so don't worry about it. And again, then in the last week, I want you to also look at some aspects of knowledge. How can we look at human rules in order to help to make our intelligent agents even more intelligent by telling him some kind of strategies that he might or might not apply. And again, so there's a lecture less than for machine learning, because we also want to spend the last lecture on ethical questions and on philosophical question of AI, because that should also not be forgotten. And we'll also provide a test exam, because what you will have to do is pass, and that's the main part of the course, the digital exam, which I think is on the Wednesday at the last week or so, but you have to look it up. So the exam counts for 75%. So this is really the core of what you have to do. And basically all the theoretical material that I explain in the lectures, Michael explains in the lectures, and that we are practicing in the working groups is also being asked in these digital exams. There's a test exam, a practice exam, so that you know what kind of questions you can expect. And I think if you really come to the working groups, the theoretical working groups, where you practice all these questions, I think you will be fine. That would be my advice. Come there, or at least look at the questions. There will be solutions to the questions as well. And if you think you do this better in your own time, that's your own decision as well. That's fine. And you will have to do this for all the topics that I just went through. As I said, there's also a practical part, and that is on programming. And as we know that several of you do not know how to program, it would be extremely unfair if we would score you on your programming qualities unless you had the chance to learn it first. So the way we want to do this is that there is a set of worksheets on which you have to work, and you have to try to make implementation. And the way, what you have to do is to keep a log and tell us what you do in order to try to solve the problem. So which were the types of code that you wrote? Just give a good motivation that you tried hard, and if you tried hard, then you will get the points. There will be no grading for these worksheets. Either you get them or you don't get them. There will be 10 points for the machine learning one and 10 points for the search one, and 5 points for the knowledge one. And you need half of the points. So you need one of the big one and the small one, or 2 big ones. So you need 2 of the 3. Basically, just submit something that summarizes the work that you have done. We haven't done that before, so it's also a leap of faith from our side. The idea is that we really want to encourage you to get onto the programming, write code, try it out, talk to the TA, so you have lots of opportunities to talk to student assistants who will help you with the basic problems. So this is the encouragement. Don't be despaired about that. You will not fail the course if you do not manage. You will fail the course on this part if you do not try. That is the attempt here. So we have 3 minutes before we have a break. And I think on slide 25, there is a lot of material to come, but we're good in time.